Hello, everybody, and thanks for joining us live. I appreciate you taking the time. And if you're watching this recorded, thanks for taking the time to review it later. Today, I'm going to focus on a variety of topics. And quite frankly, they are somewhat random topics. Some are small and some are large, but they all fit in one category of simply being topics that over the years, I hear people over and over and over getting confused about them. Sometimes it's because of preconceptions. You come into networking, you know some things, and what you knew before doesn't really jive with the details once you dig into it, so you confuse yourself. Or maybe it's a terminology issue, or maybe it's that you don't make the mental leap when comparing different subject areas. So I'll walk through 7 or 8 of those here on the presentation today, and I would ask that you, if you have questions, go ahead and ask them in the Q&A window. And at the end of each of those topics that are, roughly 5 minutes apiece, I'll stop and catch questions in context. So if you're thinking you have a question on that particular topic, go ahead and type it in. We'll still do questions at the end. It just might be easier to handle questions per topic as we go along. So that's the game plan for the next bit. I do have one more webinar scheduled with Brett and Cisco Learning Network coming up. It's just after New Year's. It's about the last days, well, at least the last days before passing your CCNT and CCNA exams. So in that one, we'll talk a bit about last week or so preparation tactics, but we just won't talk about tactics. Once we pick a tactic that might, say, apply to configuration or show commands or concepts, we'll dig down a little and show some examples of that and give you some tactics for how to go about doing your final preparation. All right, that's the setup. So let's take a look at our first topic. Now, one of the first things that people tend to get confused about has to do with that title up there, Layer 2 Switching of Layer 3 Packets. So here we've got a pretty small network. We've got some LAN switches, some routers, and some hosts. So let me set up the design for you for a moment and then talk about what I mean by Layer 2 Switching of Layer 3 Packets. So we've got host A, it's got an IP address. We've got router R1, and on that same LAN, it's got an IP address, and it's, of course, in the same subnet. Then down at the bottom, we've got host B and router R2, and those, of course, have IP addresses, but they're in a different subnet than host A and router R1. Simple enough, right? The serial link, it has IP addresses on each end as well. So if you've gotten into your studies and you've learned IP version 4, probably about midway point through learning for ICND1, that should be pretty basic stuff. Before that, you will learn how those switches do layer 2 forwarding of Ethernet frames as well. The challenge becomes that sometimes people get confused when they combine what those switches in the middle do with what those hosts and routers do with IP packets as well. So to fill in the rest of the picture, host A and R1 each have a MAC address. Host B and R2, they also have MAC addresses. But those switches in the middle, when they switch or forward traffic, they switch layer 2 Ethernet frames who happen to encapsulate or hold an IP packet. So how do those switches work when there's an IP packet in the middle? Is there anything different going on? What can we ignore? What can we not ignore? What do those switches actually do? And that happens to be an area where people can get confused combining the topics. A lot of times people truly understand how layer 2 forwarding or switching works, how layer 3 routing works, cram them together. It's a little ambiguous at times. So let's walk through an example. I've taken just the top half of that former figure, same IP addresses, same MAC addresses, same device names. And we'll do something very simple. We'll just put a network engineer at host A, and they're testing the network, and they issue the ping command, ping 1119 to ping R1's IP address. And for the sake of this discussion, A has a nice full ARP table, so A knows R1's MAC address is 0200.333.333.333. So what does host A do? It builds something like what you see toward the top of the screen. It builds an Ethernet frame with an IP packet inside of it, and not shown, the ICMP echo request. But important to us, there's an Ethernet header and an IP header. That Ethernet header has a destination MAC address. The IP header, of course, has a destination IP address. And we see the values below that rectangle. The destination MAC is R1's MAC. The destination IP is R1's IP address. So let's pause for a moment. I've been talking nonstop for about 3 minutes here probably. What do you think layer 2 switch, switch 1, and layer 2 switch, switch 2 will think about in order to make that message at the top of the screen flow from host A through switch 1, through switch 2, over to R1? Well, as it turns out, as layer 2 switches, they ignore the IP header. Layer 2 switches, to forward messages, they look at the Ethernet header, destination MAC address, and make a forwarding decision, in this case, based on the destination MAC of 0200.3333.3333. So switch 1 would receive that frame from host A and forward based on the destination MAC. Switch 2, same logic. Doesn't really matter that there's an IP packet encapsulated after the Ethernet header. So that's one thing that can sometimes confuse people. It's not quite as common as the next few that I'm going to talk about connected here. All right, so far so good. I'll probably open up the floor for questions in about 2 minutes because I'd like to link this in to the discussion of ARP. So layer 2 switching key points. They forward, layer 2 switches forward based on the destination MAC. They ignore the IP header and the destination IP address. Some people get hung up by that, not many. But what people do tend to get hung up on in that environment for this previous example is that sometimes people think you need ARP tables in the switches for the purpose of forwarding those frames. The switches do not need their IP ARP tables at all for the purposes of forwarding those frames. So let's talk about that for a few minutes before we open up for questions. So let's focus on those 2 layer 2 switches in the middle again and think about ARP. So we're going to repeat the same story. Host A is going to ping router R1 again, but this time let's assume that host A has nothing in its ARP table yet. That is, host A does not know R1's MAC address is that address that ends in 3s. So when host A issues the ping command, or the user does, host A instead creates a message like the one above, host A there now. It's got an Ethernet header, and then it's got an ARP header. Piece of trivia, ARP is actually a different protocol than IP. It's not encapsulated in IP. It looks similar, but so let's take a look at the Ethernet header. It's got a destination MAC address of all foxes and a source MAC address that matches host A. And then in the ARP header, there's a source and a, quote, target address. Think of the target address like the destination address in an IP header. In other words, this is an ARP request looking for target 1119, basically asking the question, hey, if you're 1119, what's your MAC address? That's the classic ARP broadcast or ARP request. And that's going out of host A's NIC towards switch SW1. So ask yourself again, what is switch 1 and switch 2? What are they going to do with this message, if anything? Well, they're layer 2 switches. Layer 2 switches only care about the destination Ethernet MAC, so that header after the Ethernet header, the ARP header, they ignore it. They don't process the ARP. They just look at the Ethernet destination address, and since it's a destination address of all foxes, the broadcast address, switch 1 says, hey, I'm going to flood this thing. Now, it didn't draw a lot of other interfaces on switch 1, but that frame would be flooded out all the other interfaces in that same VLAN on switch 1. You get over to switch 2 floods it, and that ARP request makes it over to R1, so R1 could then reply.